find each integral. Just to remind us what we were doing. Suppose I gave you the integral, part A, the integral of, let's see, let's do x, 2x plus 3, 1 squared dx. How would you do this integral? Foil it out. So we have rules, right? There's a couple of things we learned. For integrals, one of the most important rules right now is the power rule for integrals, which says if you have x to the n, what's the integral of this?
X to the n plus 1.
X to the n plus 1 over n plus 1 plus constant. Right, so this is an indefinite integral of x to the n. So we like things of this form, x to a power, because then we can just add 1 to the power and divide. This is not of the right form. It's not just x to a power. So if you square this out, if you actually FOIL it, you can put it in the right form and then do the integral. So I would do, I guess we can do some scratch work down here. We have to do 2x plus 3 times 2x plus 3.
4x squared plus 6x.
Yeah, so if you multiply this out, you get 4x squared plus 6x plus 9. Right, because plus 12x. Right, because in the middle you'll have 6x from here and 6x from here. So you'll have 12x is in the middle. So this integral is really the integral of 4x squared plus 12x plus 9 dx. Now, because each of these terms is separated by a plus sign, I can do the integral individually. So start with the integral of 4x squared. What's that? Yeah, so leave the 4 alone because it's a constant multiple, and then add 1 to the power and divide by it. So I left this guy because it's a constant multiple, and then I integrated x squared. Plus, leave the 12 alone, and then integrate the x. X squared over 2, right? Add 1 to the power and divide. What about when I integrate this 9 here? You just get 9x. Right, when you integrate a constant, you just tack on x. And then, so this is good. Plus c, since it's an indefinite integral. And then probably you want to clean it up a little bit. Right, this will be 4/3 x cubed plus 12 over 2 is 6. So that's pretty good. We remember? Or we don't remember? Questions? What if I gave you something like integral of 9 plus 9 tan squared theta d theta? What do you do with this?
Factor out 9, figure out the
Right, so with the trig functions, when you have an integral that has a trig function in it, you want to make it look like one of the formulas. Right? You only know the integral of so many things for trig functions. Right? You know the integral of sine d theta, you know the integral of cosine, you know the integral of secant squared, you know the integral of cosecant squared, then you know secant tangent, and you know cosecant, cotangent. Right, so I wrote these down last time, you should have them in your notes. But what I'm saying is if you want to do this integral, you have to make it look like one of these, because these are the only integrals we know for trig functions. So you need to play some sort of trick here to turn this into one of those integrals. And kind of what should be floating around, well, what's floating around in my head is that I know 1 plus tan squared theta equals secant squared theta. Like this is one of my identities from trig, one of my Pythagorean identities. So if I can apply this, I can get a secant squared theta, which I know the integral of. Unfortunately, I don't have 1 plus tan squared, I have 9 plus 9 tan squared. So the trick is to factor out the 9. Right, if you factor a 9 out of both terms, you then have 9 times 1 plus tan squared. And at this point, you can apply your identity. So this will become integral of 9 times, instead of writing 1 plus tan squared, I'm going to write secant squared. Then because the 9 is a constant multiple, that'll just follow down. And then you need to do the antiderivative of secant squared. So what do you derive to get secant squared? Tangent. Tangent's the thing that you take the derivative of to get secant squared. So when you go backward, the integral of secant squared is tangent. Plus a constant. So if you're not dealing with trig functions, you want to do all of your algebra so that everything looks like x to a power. If you are dealing with trig functions, you want to apply an identity so that you have one of these 6 basic integrals. So find a function that fits all the conditions. And we'll say, I'm going to give you two pieces of information. I'm going to give you that f prime of x is equal to 3x squared minus 2x cubed. And then I'm going to tell you that f of 0 is equal to set. So I'm giving you the derivative of a function, and I'm giving you one piece of information about the function. I want you to put these two things together and find the formula for the function. That's what this is asking, find the function. So figure out what f of x has to equal. Sort of the starting point here, the main idea is that I've given you a derivative, so you can get back to the original function by taking the integral. So f of x will equal the integral of f prime of x. Because the indefinite integral is the same idea as the antiderivative. So it gets rid of the derivative. Which means my whole game comes down to taking the integral of 3x squared minus 2x cubed. But, so f of x should equal this. 3x squared minus 2x cubed. And then how do we do this integral? Yeah, so ignore the constant multiple, right? Ignore the 3. Add 1 to this power and divide by it. So 3x cubed over 3. Minus 2, so ignore the 2 for a second. X to the 4 over 4. Now you got to be careful, since we did an indefinite integral, you absolutely need a plus c. Because this is technically the family of all functions, right? This is all possible functions that have this as the derivative. So our function is going to be one of these, but we have to now go in and figure out exactly what the c is.
7.
It is in this case. And why is that?
Because when you put 0 and you're going to get 0 for the other factor.
I reduced it real quick. So I have plus c here, but I need to satisfy this second condition still, right? I need to make sure that when x is 0, f of x is 7. So when x is 0, f of x equals 7. So if I put 0 in here for all the x's, that should equal 7. 0 should be f of x. But everything drops out, and I'm left with the equation that c equals 7. So my answer to the question, find a function that fits these two conditions, what will my function be?
X cubed minus x to the 4th over 2 plus 7.
Okay. So there's my function. So all this extra piece of information here, this extra point, what this allows me to do is solve for c. For the constant of integration.
On that last f of x line, is that supposed to be 0 to the 4?
Oh, to the 4th, thank you. Yeah, I was just putting in 0 here, so there's no reason to change it to the square. Thank you. So, kind of a related question. What happens, what changes if I instead of giving you f of 0 equals 7, I gave you f of 1 equals 7? What if I gave you this guy? What would change? So when x equals 1, f of x equals 7. What do I do different? Does it change the integral? No, if I just change this point, right, if I just give you another point, instead of f of 0 equals 7, f of 1 equals 7, this has nothing to do with the integral. Right? This doesn't come in until right here. Right? Until after we do our integration. So what you would have to change is you'd have to come up here and solve for c again. So you'd solve for c by plugging in 1 for x. And putting 7 on the other side. So then you have a little more work to do, right? If it's not 0, you have to actually calculate this. So 1 minus 1/2 plus c equals 7. 1 minus 1/2 is a half. Plus c equals 7. So what's c equal? 6.5, right? You subtract the half over the other side. C will equal 6.5. Or if you don't like mixed numbers, which I tend not to, 13.5. So in this case, you would end up with, in this condition, you would end up with f of x equals x cubed minus x to the 4th over 2 still, but then you'd have to put plus 13 halves instead of 7. A lot of times this will give you 0 here. A lot of times in the problems like this, you will have f of 0, only because it makes your life a little easier. Right? But I don't want you to get the pattern down that this is always c. Right? This isn't necessarily always your constant. It was in the first case because we had f of 0, but if I change it to f of 1, then c changes. And so just do the work and figure it out. One more example similar to this, but before I erase it. So you remember a long time ago, many moons ago, we talked about something called a position function. And we usually labeled the position function s of t. And what it told you is how, like, we usually did it with throwing a ball up in the air or dropping a ball off of a roof. So this would tell you, like, how high the ball is at any time t, like the position of the ball at any time t. And then we talked about the velocity of the ball at any time t. And we talked about the acceleration a little bit of the ball. Remember how these were related? Yeah, each one is the derivative of the one above it. Right? So if you did the derivative of position, d dt, you got velocity. If you do the derivative of velocity, you get acceleration. Or another way of saying that is that velocity is equal to s prime of t, and acceleration is equal to s double prime of t. You do two derivatives to get to acceleration. Which means you can now, given what we've just talked about in this section, you can now go backward. Right? If I give you an acceleration, you can apply an integral to go back to velocity, right? You can do an integral with respect to time. Integral of a of t dt. And you can go back from velocity to position by the integral of v of t. This is kind of cool. This is kind of interesting because we actually know the acceleration due to gravity on Earth is either negative 9.8 meters per second squared or negative 32 feet per second squared. So using that information, we can go backward and build a position function. So that's the example. Ball is dropped from a height of 20 feet. Any object that's dropped has an acceleration. Any object falling has an acceleration due to gravity of negative 32 feet per second squared. Find a position function height of the ball. Above the ground. So basically what I'm telling you is acceleration. I'm telling you we know acceleration. The acceleration of this ball, no matter what the time is negative 32. That's what this is. And what I want you to do is use all of your cunning to go backward to the position function. So you're going to have to do two steps. You're going to have to get velocity first, and then do another integral to get position. Okay. So as soon as they tell you that acceleration is negative 32, you can get velocity by taking the integral of the constant negative 32. So what's the integral of negative 32? Negative 32. T or x? T. Because I put dt. But then you have a constant, right? Now, at this point in time, I only have velocity. Velocity is negative 32t plus c. But I'd like to solve for the c using any information I might have. Can I solve for this? So velocity, what does velocity mean? Velocity means the speed that the ball is going. So when the time is 0, when it's 0 seconds, meaning that I just about to let go of the ball, so right on the edge of me letting go of the ball. What's the velocity of the ball? 0, because I'm not putting any speed into it, I'm just dropping it. So at the instant that you let go of the ball, the velocity is 0. That allows me to solve for c. This is because it says dropped. And this is what's telling me v of 0 equals. If I wanted to have some other velocity, I'd have to say I threw the ball down at 15 feet per second. I'd have to give you some initial velocity. But if you ever see the word drop, that means there was no initial velocity put into the object. So what does this mean about c?
C equals 0.
Right, because now you have v of t equals negative 32t plus c. You can plug in 0 for t and solve for c. Right, when t is 0, v is 0. That's what this is saying. So if you put 0 in here, this side has to be 0. And if you solve this equation, c equals 0. Okay. Which means my velocity function is negative 32t plus 0, which is kind of stupid. Write it like this. That's just negative 32t. But I don't care, I didn't ask for velocity, I want a position. So how do I go from this to position?
Take the integral.
Do the integral again, go backward one more time. Right, the position function is going to be equal to the integral of the velocity function. So the velocity function is negative 32t, so I do the integral. What do I get when I do the integral here? Negative 16t squared, or if you want to be pedantic about it, leave the 32 alone, and then add 1 to the power on the t and divide by the same thing, right? That's our power rule. But you have to add
Plus C.
constant. This is a different c, so let me call k. It's not the same because we got it from a different integration.
Plug in 0 first.
Yeah, so let me clean this up. S of t equals negative 16t squared plus k, and we have to solve for the constant. When I plug in 0 for t, what should my position be? 20 feet. 20 feet. Right? Because initially, when this whole process starts, the ball is 20 feet high. So this is S of 0 equals 20. So when I plug in 0 everywhere for t, negative 16 times 0 squared plus k, I should get out 20. Which means my constant of integration here function is negative 16 t squared plus 1. Well, first of all, to get from acceleration to position, you integrate twice. And along the way, each step, you want to solve for your constant using the information given to you in the problem. Okay, what's this mean?
And you could find the position of the ball.
So, yeah, so this tells you the height of the ball at any time t. So, follow-up question. I'm going to ask you this, you do it, and here's your follow-up. When does the ball hit the ground? So in order to hit the ground, that means your height has to be 0. All right, you're on a 20-foot building, or wherever you're at. You drop the ball, which is obviously purple, goes down. This is position equals 0. And what this function is going to do is, if you plug in a t, it'll give you how high you are. So if I ask when does the ball hit the ground, I'm asking you to plug in position equals 0 and solve for t. When tells you to solve for t. Hit the ground tells you to set S of t equal to 0. So you do it. Subtract the 20, divide by negative 16. T squared equals negative 20 over negative 16. T squared equals 5/4 if you reduce. Square root. T equals plus or minus root 5/2. Actually, do we care about the minus? No, we're not going to say the ball hit the ground root 5/2 seconds in the past. Oh, did you get an approximation for me?
Yeah.
Say again.
1.12.
down pretty quick, huh? Alrighty. Questions? So kind of the point of this section 4.1 was to be able to do indefinite integrals, right? These basic rules, the power rule where you add 1 and then divide, right? Knowing the integral of sine, cosine, and secant squared. That was the major point. These last two examples are kind of applications of integrals. Okay. The first one where I gave you f prime and I asked you to find f, right? That's one application of integrals. This is just a slightly deeper application. I gave you s double prime. Right, initially I gave you acceleration, which is s double prime. And I asked you to go up and find the original function. So these are just applications.